So let us have an example, um, how we can do it. And then we'll come back here. So in a spreadsheet software like Excel or Google Sheet or any other kind of spreadsheet software, you can do it very easily. Okay, can you see in the screen? So the linear probability model and the Logit model can be very easily implemented in a very standard spreadsheet software. For example, Microsoft Excel or Google Sheets. To give the example, sorry, let's suppose we have actually identified that three factors are very important, for explaining the default behavior of a particular type of customer. So what are the three factors? One is the leverage, represented by debt over asset, debt, total debt divided by total asset. Okay, we give the name X1, we give the notation X1. Then the second factor is profit margin. That means to say it simply, net income divided by sales. That means it is net profit margin actually. Okay, we are representing it with the notation X2. And the third one is current ratio. Let's say this is current asset divided by current liabilities. Okay, and let's suppose it has a notation of X3. And we want to explain the default attitude of this type of customer using these three variables. So we are giving the notation default as D, where we will have only two possible values. One is 1 and the other one is 0. So what does 1 mean? 1 indicates default and 0 indicates no default. Now, for this particular customer type of customer, we can collect information. Let's say we have 10 customers, 1 2 3 4 5 6 7 8 9 10, and we have seen that uh, uh, some of them have a default. That means this one, the third one, fifth one, eighth one. Okay, we have got three customers who has defaulted, and their value of leverage, that means debt to total asset, is 73%. The value of profit margin is 0.12, that means 12%, and current ratio is 0.72. This, for the second customer, it is the leverage was 47%, profit margin was 26%, and current ratio was 1.02. And the third customer who has default, he had the value of leverage of 83%, very high. Okay, then profit margin of 1% only. So this customer is really not very good one anyway. And the current ratio is only 0.07. So very high degree of lack of liquidity. Okay. Now think about the customers who has not default, no, representing the value of 0. For them, we are getting the values of X1, X2, and X3 as well. And we have arranged all these values in a spreadsheet like this. Is it possible to do? Actually, it is possible to do. Now we can collect the information. If we really want to do the analysis, then we have to collect the information. So after getting it in the spreadsheet software, then what we can do, we can actually uh, we can use the tool called data analysis. Okay, from this is the example from Excel. So from Excel, we can go to data, then click data analysis. Then you will get this one, a dialog box where we have the regression option. So we have to select the regression option, then click OK. Okay, after you do that, then what will happen? You will get another dialog box to provide the input and input ranges. That means what is the Y value, that means what we want to explain and what are the explanatory variables. So we have to select those here, and then we have to provide the output range. That means where do we want to get the output, like this one, F2. Okay, I have selected F2 here. And after that, if you click OK, you will get the whole table of regression like this. Okay, I will show you practically how to do that. So this is the table. This is the regression output. You don't need everything here. You only need several things. Okay, at first you have to check if the regression model is overall significant. So you have to look at this one. We have plenty of information here, but we don't need all the information. We need only a few. Okay, so you have to look here if the model itself is significant or not. You can see it is 2.92 times 10 to the power minus 11. So this value should be less than less than 0.05. Okay, so you can understand, because it is 10 to the power minus 11, that means it is a very, very insignificant, a very, very low value. So the lower it is, the more significant the model is. So overall, the model is very significant. Not only that, you can also see here adjusted R square. Adjusted R square means to what degree this model can explain the default behavior. So you can see here 84%. So this is also very high. Okay, and this is good because this model can explain the default in 84% cases approximately. Okay, so this is just diagnostic if the model is working good or not. Then you have to look at this column. Okay, this is the intercept. This is the beta coefficient for x1. So what is x1? Leverage. Okay, x1, beta coefficient for x2, and beta coefficient for x3. But before going into the detail, we have to look at the p-value. The p-value must be less than 0.05. So you can see the intercept p-value is less than 0.05. X1 coefficient p-value is also less than 0.05. All are less than 0.05. So we don't have to think, we don't have to be worried. Let's say for x2, we get this p-value greater than 0.05 or very high p-value. In that case, we will exclude this one. We will conclude that x2 is not important at all. But in our case, all are significant. Okay, significant. That means less than 0.05. So we can take all of them. So this one minus 0.266, that is beta 3. What does it indicate? It indicates that the default value is negatively, because we have a negative sign here. So it is negatively related to x3. That means x3 is the current ratio. So the higher the current ratio, the lower the indication, lower the probability of default. Okay, lower the default, because we have given d is equals to 1 when there is a default, isn't it? So the negative relationship indicates that high current ratio indicates low default, which is actually theoretically explainable, because if you have a high current ratio, that means you have more current asset relative to your current relative to the current liabilities, and that indicates that the customer has the ability to provide cash, from the current assets. Okay, and if you think about x2 value, the beta coefficient of x2, again you can see it is negative. That means the higher the profit margin, the lower will be the default. And the coefficient is 1.11. And x1 is leverage. So you can see positive relationship. So higher the leverage, higher the default. And we have another thing, intercept. Intercept is actually something that is not explained by x1, x2, and x3. Probably we should have taken more x4, x5 later on, but we have not taken that yet. Or there are many insignificant or many unimportant factors that you cannot afford to take into the analysis. Okay, so in that case, those will be accommodated in the intercept. So intercept is also important. You also have to, because it is significant. You can see p-value is 0.00005, less than 0.05. So intercept is also important. So you also have to take the intercept, which is whatever intercept, you have to put it in the equation. Okay, this is how we can find out the beta values, beta 1, beta 2, beta 3, and so on. Okay. I want to show you the whole thing in an Excel file so that you can understand it. So you can see that on this Excel sheet, we have the default experience of 30 customers, 30 customers in the past. And we also have collected the values of these three variables, x1, x2, and x3 for each of these 30 customers. So these are our experience. These values are from our experience, right? And what do we indicate by this x1, x2, and x3? We can actually type it here. So this one is debt over asset. And this one is profit margin, net income over sales. Okay. Net income over sales. And this one is current asset over current liabilities. Indicating leverage, profitability, and liquidity. Okay. And this is the default experience. So to understand, how these three important characteristics influence or affect the default, we can run a regression. So to run the regression, what we do, we go to data, we can click data analysis, click regression, then okay. Okay, you can delete whatever value is here so that you can do it from the beginning. Okay, now input y ranges. So what do we mean by y? Y is the dependent variable. That means the variable that we want to explain. So we will select the range of values of the dependent variable. So starting from the title, label, because we have selected this one. Okay, if you check this one, that means that the whatever range you select, on top of that you will have the name of the y range. Okay, so because we have checked this one, so we will take including the title. Okay, you can see it is from A3 to A33, A3 to A33. You can also type it, you understand that. Then input x range is from here until here. Okay, we'll select from B3 to D33, including the label. And we will not claim that constant is 0 because we have actually constant. And we don't have to go into the detail because this is not statistics class after all. We will take only whatever is needed. Okay. Now the output range. Now where do you want the output? Let's say we want it here. So click here and then click OK. So you have got the regression. Now check if it is significant. Okay, I am highlighting the important cells so that you can understand. So this one is important. You have to check this one. This is optional. If you want, you can check. If you don't want, it's okay. Then you have to check these values if these are significant, because if this is not significant, let's say 0.0 instead of 0.03, x1, the p-value of x1 is like 0.23, 0.235, something like that, then we will exclude this variable. But in our case, we can see all are important here because all of them have value less than 0.05. Okay, so from here you can understand the beta. These are not beta actually, the betas are here. Okay, betas are here, so we will provide a different highlight here. So these are the beta and also the intercept. So from here we can identify the intercept. So the intercept, then B1 for beta 1, then B2 for beta 2, and B3 for beta 3. So we can just link all those. beta 1 is equals to this one, beta 2 is equals to this one, and beta 3 is equals to this one. And to make it better looking, I will actually reduce the decimal point to 4 digits. Okay, so these are the beta values and the intercept value from our past experience. Now let's say we have got 3 customers who want financing from us. Who want financing from us? Client A, client B, and client C. And from our past experience, let me write it down. Past experience about client class J. Okay. So all of them are client class J. Now we have got 3 customers from this class. Okay. New client class J. New client of clients actually. New clients of class J. So we have got the new clients of class J in this way. Okay. Let me delete it and link it with the value we have got in the previous worksheet. So this is the intercept. Then this is the beta 1. This is the beta 2. And this is the beta 3. Okay. Now what we need to do, we need to collect these 3 variables, okay, leverage, profitability, and liquidity of these 3 customers. We have to collect what is the value of x1, x2, and x3 of these customers at present. Okay, we have to collect this information. Okay, because it is a quantitative model, definitely you can collect it from their financial statements or from different other legitimate sources. Let's say to make it easier to remember, let me copy the name of the values. Okay. So the first one is actually debt to asset. Let's say the first customer has debt to asset of 10%. Second customer has 75%. And the third customer has 0.45, 45%. And the profit margin, okay? The profit margin, let's say the first customer has a profit margin of 20%. That means 0.20. First customer, okay, or client A. Client B has a profit margin of 0.35, and client C has a profit margin of 0.15. And the current ratio over the current ratio for client A, let's say it is 1.5. For client B, let's say it is 0.42, and for the client C, let's say it is 1.2. Okay. Now we can get the score of each of these customer based on the model, based on our beta values and intercept that we have found in our regression analysis, okay, in the linear probability model analysis. So how do you get it? You get it by using the formula. That means for client A, at first intercept does not have anything to multiply. Okay, intercept is a standalone value, plus beta 1 times x1 plus beta 2 times x2 plus beta 3 times x3. Okay, you can do it in similar manner for client B and client C as well. But in Excel, as you know, it is easier for us if we actually log the links, then we can just copy the formula down and it will be done. So what we want to do here, we want to get the fourth row fixed so that when we copy down, all the fourth rows will remain constant. Okay, so before 4, we'll type a $sign so that we can copy it directly. So we have got the scores. For client A, the score is 0.2599. For client B, the score is 0.7552. For client C, the score is 0.5978. And you can understand in our original regression analysis, 1 means default and 0 means no default. So the higher the score, higher the probability of default. So who is highly probable of being default? Client B, because client B has the highest score here. And who is the least possible defaulter? The client A. Client A probably will not default because it has the lowest score among these 3 clients. So this is one score, but we cannot really say that this is the probability of default. We due to some mathematical limitation of this model, we cannot say that client A has a possibility of 25.99% default, or client B has a probability of 75% default. We cannot say that. If we really want to find what is the probability of default, then we have to do one kind of transformation, which is called logistic transformation. We have to do a transformation. So we can say probability of default. So how do you get the probability of default? Logit model. Okay, so we need a transformation. Let me tell you how you can do that. There is a formula for that. Let me show you. So the formula will be 1 over, okay, let me copy the formula first. This is the formula. So it will be equal to 1 over, within bracket, 1 plus exp within bracket negative this score, bracket close. So this is the probability of default measured based on the linear probability model and also the logit model. So now we can directly say what is the probability of client A of default by client A. We can say 56.46%. What is the probability of default by client B? 68.03%. What is the probability of default by client C? 64.51%. Now you will decide, based on what is your Islamic bank's decision, what level of probability of default will you tolerate? If you say that, well, it must be less than 60%, then only client that you can finance is client A. Hmm. But definitely, this is just an example. We have got quite high. All values are very high. 56% is not also low. So this is how you can identify the client that has a lower probability of default and screen them out from the high default probability clients so that you can finance them.